So what exactly is force? Force is either a push or a pull on an object. So when we push something, we are applying force, and when we pull something, we are actually applying force as well. So the young boy in the picture or in this video is actually pushing the table. So that is a pushing force. Then this man is pulling the bag, and that is a pulling force. So a force is either a push or a pull on an object. But here is one interesting fact. Whether an object is moving or stationary, there are always forces acting on it. So let's look at some of the forces that act on objects. For example, if you look at this tree, the apple fruit on the tree is being influenced by a type of force known as gravity. And gravity causes the apple to actually fall from the tree. So as the apple is hanging up there on the tree, gravity is pulling it down. So what exactly is gravity? Gravity is basically a type of force that pulls object towards the earth. So gravity pulls object towards the earth. If not for gravity, when you and I jump, we shouldn't fall back to the earth. We should just keep moving, going into space. But gravity pulls us back to the surface of the earth. There is a different type of force known as normal force. Normal force is a type of force that a surface exerts on an object that is in contact with it. So in this picture, you can see the box placed on the table. So the table is exerting an upward force, which is a normal force on the box. And then gravity is also pulling the box down towards the earth. So what exactly is normal force? That is what is appearing on your screen. The force exerted by a surface on an object that is in contact with it. Now, there are other types of forces that exist in nature on objects that are moving. For example, a bird. As a bird flies, there are 4 types of forces acting on the bird. And what are those types of forces? Let's look at them. We have drag or air resistance, gravity, lift, and thrust. Now, out of these 4 forces acting on the bird, 2 of them are natural forces, and the other 2 are forces generated by the bird itself. Now, which of these 2 forces are the natural forces? Definitely, it is the drag or air resistance, and then gravity. So gravity is trying to pull the bird down, and air resistance is also trying to pull the bird backwards. But as the bird flaps its wings, it moves through the air. That is what we refer to as the thrust. But what exactly do we mean by the lift? The lift is just an upward force that enables the bird to float or fly. That is the lift. And lift can also be found in man-made objects. If we move to the next slide, we'll actually get to see that. And the thrust is a forward force that propels the bird, in this case the bird, through the air. But it is a generic term that refers to the force that moves objects through fluids, say air and water. So these are the 4 main forces acting on birds. Now what human beings did is to copy nature to make airplanes. And these same 4 forces, drag or air resistance, lift, gravity, and thrust, also act on airplanes. So as this airplane is flying, these forces are present on the airplane. And what are those forces? We are talking about lift, gravity, drag, and thrust. And out of these 4 forces, 2 of them are natural forces, and 2 are forces generated by the airplane. And what are the natural forces? Gravity and air resistance or drag are the natural forces acting on the plane. Gravity is trying to pull the plane down towards the earth, and drag or air resistance is trying to influence or resist the movement of the airplane. So drag is trying to drag or pull the airplane back. Gravity is trying to pull it down. And the forces that are generated by the airplane itself are the lift and thrust. The lifts are generated or provided by the wings of the airplane, while the thrust is provided by the airplane's engine. So that is how the airplane is able to overcome the gravity and the drag to be able to float and move in air. Now, as we ride bicycle, there are other types of forces that also act on us as we ride the bicycle. This brings us to an interesting force known as friction. Friction is a type of force that exists between two objects that are in contact with each other and sliding over each other. So the objects should be sliding over each other. Then we have friction present. One interesting thing about friction is it acts in a direction opposite to the direction of motion. If you pay close attention to the bicycle rider, you will see that as he's moving forward, we directed the friction to be moving backwards. So friction acts in a direction opposite to the direction of motion. There are two other forces acting whilst you are riding a bicycle. That is normal force and gravity. So the normal force is the force that the ground applies on the tires of the bicycle. And then gravity is the type of force that is trying to pull the bicycle and its rider towards the surface of the earth, to keep them in contact to the surface of the earth. So at every point in time, these are the three types of forces acting on the bicycle and its rider. There is also another type of force acting on it, but it has not been shown. Especially on a windy day, that will be air resistance. So that force, although not shown here, can also exist. This brings us to an interesting concept, or fundamental concept in physics known as streamline bodies. When we say an object is streamlined, it basically means that the object is designed in such a way that it finds it so easy to move through fluids. And when we say fluid, we are referring to either water or air. So animals or fishes are designed with streamlined bodies, and it is because of this design that's why they are able to move through water with ease. So the shark has a streamlined body, is shaped in such a way that it moves easily through the water. One interesting fact is that aside fishes, human beings are also able to swim through water. So as we swim, what are the forces that act on us? So at every point in time, whilst you are swimming, there are four types of forces acting on you. And these forces are thrust, gravity, upthrust, and drag. And drag is also known as water resistance in this scenario. Now, out of these four forces, three of them are natural forces. That means they are forces that are generated by the swimmer's environment. And then the last force is the force the swimmer generates himself to overcome these three forces. So what are the three forces acting on the swimmer, which are natural forces? We have gravity. So the gravity tries to keep the swimmer towards the surface of the earth. Now, the upthrust is that upward force that enables the swimmer to keep floating in the water. And then as the swimmer swims through the water provides some kind of resistance that makes it difficult for him to move. That resistance is what is known as the drag. But the swimmer then moves his hand rapidly to overcome these three forces. And the force he uses to overcome these three forces is what is known as the thrust of the swimmer. So now the question is, how does the swimmer do all he can to overcome these three forces easily with his thrust? The first thing he does is to check what he wears. So you can see that he's not wearing a trouser and maybe a pajamas or something. He's actually wearing what we refer to as a wetsuit and a cap. So these wetsuits and cap are actually smooth, have smooth surface, and they make it easy for the swimmer to overcome the three forces. And also, as he swims, you would notice that he tried all his possible best not to splash the water too much. So he avoids too much splashing of the water, because the more he splashes the water, the difficult it becomes for him to swim through the water. Now, human beings have actually learned a lot from the streamlined bodies of animals. and we've applied that knowledge when it comes to swimming and when it comes to design of vehicles. So if you look at this track, it is moving on a highway at a very top speed. The track is designed in such a way that it makes it easy for it to overcome air resistance. What do we mean by air resistance? The air resistance is that force that the air exerts on the vehicle as it is moving. So this force tries to minimize or slows down the track. But the track is designed with a unique feature that I'm pointing to you right now. If you look at the front side of the car, you can see that it is curved this way to reduce the air resistance. So there are some questions here for us. Which forces slows down these lorries, this kind of lorries, because of their size? You see, the car is really big, or the lorry is really, really big. So as it is moving on the highway, air resistance tries to slow it down. So that's the kind of force that slows down the vehicles whilst it is moving. And the next question is this. You see that design feature I've pointed to you. What do you think the design feature marked by the arrow helps the lorry to travel faster? What do you think? Well, the design feature gives the lorry a more streamlined shape which helps it to overcome air resistance to go faster. So it is now streamlined. So it's able to overcome the air resistance that is trying to slow it down to enable it to move faster. So our final question is, how do you think this shape, this design feature in the lorry or the truck helps to reduce fuel consumption or helps us to save fuel? Well, the air resistance is reduced because of the way the truck is shaped. And because it is reduced, the lorry or the truck then uses not so much fuel to travel the same distance or to travel at the same speed. If not for the design feature of this truck, it will need to use so much energy, so much fuel to overcome the air resistance. So that's how amazing it is. So far, you actually look at the various types of forces that act on objects. Whether the object is stationary or moving, we've discussed gravity, normal force, air resistance, friction. These are some of the main or fundamental forces that act on objects, whether stationary or moving. So thank you so much for sticking with us to the end of this video. Come back for our next lesson.